Hello everyone, my topic for today is errors of refraction. So I'll be starting my topic today. Okay. So what does refraction literally mean? Refraction literally means bending of light. Okay. So whenever light passes from one media to another, it has a tendency to bend, and that is what is refraction. I'm sure all of us are very much aware of the refractive mechanism, the focusing mechanism of the eye. So if this is the eyeball, this is the cornea, this is the lens, and this is the retina. So when the accommodation is at rest, the parallel rays of the light will come, and after getting refracted from the cornea and the lens, they will come to form a focus at the retina. So this is what will happen in ideal conditions, that parallel rays of light coming from infinity, provided the accommodation is at rest, will come, get refracted, and will form an image at the retina. This is called emmetropia. Okay. So as I said, this is the ideal condition. However, this ideal condition does not always apply. Okay. So sometimes we might have a cornea which is flat. Sometimes we might have a cornea which is more steep. Sometimes we might have a lens which has a different refractive index, which has a higher refractive index or has a lower refractive index, or sometimes altogether the length of the eyeball is different. So either it's very long or it's very short. So what will happen is that these rays of light which are coming from infinity will either come to focus at a point in front of the retina, or they will come to focus at a point behind the retina. So in these conditions, this EM is going to become emmetropia, right? So errors of refraction are called emmetropia, which is our topic for today. So before I go into the details of this topic, I would like to tell you a little bit about how lenses work. Okay. So this is a convex lens, alright, and this is the principal axis of the convex lens. This is the principal plane. So the point at which the principal axis will get intersected by the principal plane, this will be the optical center, you might call it O, right? There is also a point which is called the nodal point, right? The nodal point is a point wherein the light comes at this point and it will pass undeviated. So when we have a lens where the media on both the sides of the lens is the same, this principal point is going to coincide with the nodal point, and this will be at the optical center. I must tell you that this does not happen in case of a thick lens and those lenses where the media on both sides are different, right? So I must tell you here that here I am talking to you about thin lenses, right? Lenses which do not have a finite thickness. The lenses whose thickness can be ignored. So as we all know, and we must understand that this does not happen in case of the eye. Our eye is not an ideal lens. Rather, it is a system with a finite thickness. Okay, and also the media on both sides of the eye is not same. So one side we have air and the other side we have the substance of the eye, right? So this whole thing is not going to apply. Now coming to the focusing mechanism of the eye, as I told you, right? Cornea, lens, and the retina. So here I said that this is coming to get focused at the retina. So how does this happen? Because the eye is not an ideal system, so for this sake there were two systems which were basically given. Okay, there were two scientists who gave the concept. The first scientist was Gallstrand this Gallstrand, he gave the concept of reduced eye. Okay. In the reduced eye, there were two principal points. Why two principal points? Because we have two refractive media in the eye. One is the cornea and the other one is the lens. We had two nodal points. Okay. You must note that the principal point and the nodal point are not coinciding because the media on both the sides is different. Okay. And of course, because it is a lens, so it will have two focal points. Okay. So this basically was given in order to simplify. However, okay, one more thing. This is an MCQ. Must remember the concept of reduced eye was given by Gallstrand. Now, further this was simplified by a scientist called Listing. Okay. And this Listing, he gave the concept of schematic eye. How did he simplify it more? He said that instead of two principal points, there is only one principal point. Instead of two nodal points, there is only one nodal point. And of course, because it is a lens, so it will have two focal points. Now, why he did this? He considered the entire refractive surface of the eye to be one system. Okay, and that is why it will have one principal point, one nodal point and two focal points. So because of this, what happened? Making instruments, making optical instruments, understanding the optics of the eye was a lot more easier because of this concept. This also is a question you must remember. Okay, that the concept of schematic eye was given by Listing. One principal point, one nodal point and two focal points. I'll explain you a little bit more about this Listing. And what are the important questions from here? Okay. So he said that there is one nodal point. So where is this nodal point? Inside the eye, this nodal point lies at the posterior surface of the lens, the crystalline lens. Okay. And there are two focal points. So F1. This is at a distance of 15.7 millimeters in front of the cornea. So since it is in front of the cornea towards the left, there is a minus sign we'll add here. Okay. And F2, which is 24.3 millimeters. So since this is behind towards the right, so there will be a plus 24. And both these measurements are taken from the anterior surface of the cornea. Okay. Why these measurements are important, I'll tell you, but you must also remember this for your MCQs. Okay. So here I'll stress upon that the second principal point is 24.3 millimeters, and this second principal point is actually where my retina in the eye lies. So if I want to define emmetropia again, I would define it as parallel rays coming from infinity, provided accommodation is at rest, will come to focus at the second principal point, that is my retina. Alright? Okay. After we're done with this concept, now I can directly move on to your refractive errors. So what are these refractive errors? The first one is myopia. The second one is hypermetropia. The third one is astigmatism. And you must remember that presbyopia is not an error of refraction. So if you have four options, presbyopia is not an error of refraction, rather it's an age-related change. It's a physiological process in the eye. This does not come as an error of refraction. So I'll be explaining to you all of these. The first one is myopia. So it is also called short-sightedness. Why is it called short-sightedness? Because the person is able to see objects which are situated close to the eye. He will not be able to focus the objects which are placed at a distance. Okay, so why does this happen? This happens because the parallel rays of light, provided the accommodation is at rest, will come to focus at a point in front of the retina. So rather than getting focused at the retina, they are getting focused in front of the retina. So why is this happening? In the beginning of my lecture, I told you that when the conditions are not ideal, it can either be of an axial category, it can be due to a refractive category, or it can either be due to position, or this might happen if the accommodation is more. So coming to the first category, axial. Now suppose if the length of the eyeball is more, right? So if the length of the eyeball is more, obviously the rays which are coming from infinity cannot get focused at the retina and they will be focused in front. Okay, so axial. Refractive can be classified further into two types. The first is curvatural and the second is index. Now suppose if the curvature of the cornea is excessively steep. If it is excessively steep, definitely it will have more power. So the rays of light which are coming, instead of getting focused in the retina, suppose they have to get focused here, they're instead getting focused here because of the steepness of the cornea. This can either be due to cornea, this can either be due to lens. So this is my curvature category. Another category is index. In index, what will happen? There will be a greater refractive index of the lens. So if the refractive index is more, obviously the rays of the light will be bending more. So we will come to focus again in front of the retina. Okay. Position, what will happen? In positional, if my lens is placed somewhat here, more anteriorly, again the rays of the light will be coming and they will be getting focused in front of the retina. So this is positional. Another category, see, I was always talking when the accommodation is at rest. However, when the accommodation is not at rest, if the person is excessively accommodating, what will happen is that my lens, which was like this, because of excessive accommodation, will get more steep. So the power of the lens is increased more. So definitely the rays again will come and they will be getting focused in front of the retina. So these are my four categories etiology wise. When I come to my clinical picture, I will have a different classification system. So the first one in it will be congenital. Okay. So what is congenital myopia? Congenital myopia is a condition which is diagnosed approximately with 4 to 5 years of age. You will have a refractive error of 8 to 10 diopters. The good thing about this is that it is unlikely to progress. It is not going to progress. So once you correct this 8 to 10 diopters of myopia, you are done with it, right? The first is congenital. The second one, which we encounter mostly in clinical practice, which is my simple myopia. Okay, this is also called school myopia. Why it is called school myopia is because this will peak at 8 to 10 years of age, which is my school going age. So these patients, these children usually will be coming to us with asthenotic symptoms, with headache, blurring of vision. They'll be, drooping their eyelids in order to have a correct, in order to focus correctly. So this is my school myopia, and this can easily be corrected. Now another most important in terms of MCQ point of view is my pathological myopia. Okay. So this pathological myopia is the one which will also be called progressive myopia. Why is it called progressive? Because this will keep progressing. It will again get diagnosed around 3 to 4 years of age, and the person will have very high refractive error, and this will go on increasing till early adult life. So it might also come to a state of 15 to 20 diopters, which is very high amount of refractive error. So when you see these patients, they are extremely debilitated. They are not able to even perform their daily activities, and they are almost blind and have very, very thick spectacles. So why this condition is progressing? First, etiology wise, it is because of heredity Okay, and it is also because of some growth factors. Okay, so both these conditions are contributing. So because of these conditions, what will happen is that my eyeball will continuously keep on increasing in size. So if the eyeball is continuously increasing in size, definitely what will happen is that the image is again receding away from retina because the eyeball is increasing in size, and this is a progressive condition. So because of this, what will happen is the sclera is stretching, the choroid is stretching. So there's a progressive degenerative change which is going on inside the eye. So because of this degeneration, there will be choroidal changes, there will be retinal changes, there will be scleral changes, and there will be changes in the vitreous also. So this is affecting everything in the eye. Okay, there will be bleeding in the choroid, there will be increased thinning of the retina, there will be scleral thickening, there will be degeneration of the vitreous. So if we come to the clinical signs, all these clinical signs are MCQs and must be paid attention to. The first one I tell you will be optic disc. What will happen to the optic disc? Of course, the entire eyeball is very large, so it will have a large optic disc. It might have a temporal crescent, okay, or it might have a total peripapillary. Peri matlab full disc ke around there will be a crescent. So peripapillary crescent can be there. So your disc is large. It might have a temporal crescent, a crescent on the temporal side, or it can have a peripapillary crescent. Okay, first. Coming to macula. What will happen in the macula? So because this increased size of the retina will have increased amount of blood, okay, and there will be continuous hemorrhages going on. So what happens at the macula is that this is your fundus, this is your optic disc, there will be a red colored spot here, and this spot, must remember, Foster Fuchs spot, very important MCQ. This occurs because of bleeding which is happening under the macula in the choroid. Okay, so the Foster Fuchs spot in the macula. Okay, also there might be these white colored spots with heaped up pigment. Okay, this is also one important finding in the macula. Coming to what happens in the periphery of the retina, you must know that there are two degenerations. This is also an MCQ. Lattice degeneration associated with high myopia, lattice, and also snail track degeneration. Okay, so in the periphery, this snail track degeneration and this lattice degeneration. Now, because my sclera is constantly thinning, the posterior surface of the sclera becomes tremulous. It becomes very ectatic. So what will happen? This will become a staphylogram. Okay, this is called a. There will be a posterior staphylogram. Okay, this whole thing is very tremulous. It's very shaky. So the length of the eyeball definitely has increased more. So there is a staphylogram. Another very important MCQ which we will get here is the vitreous. So what basically I told you happens in the vitreous. Vitreous will also have degenerative changes, and because of this degenerative changes, the vitreous itself will have some black spots or floaters. Okay, and the vitreous which is attached to the posterior surface of the retina will start getting detached. And when you start seeing from indirect ophthalmoscopy, important MCQ again, you will have something which is called Vis reflex. Okay. So all these things are to be remembered. Okay, repeat for you. You have to remember Vis reflex. You have to remember lattice degeneration. You have to remember Foster Fuchs spot. And you have to remember a temporal crescent. All these are the findings in a pathological myopia. Okay. Now, this is the definition and the etiological classification and the clinical classification. Now, how are you going to correct this condition? So obviously explain you in terms of a diagram. Eyeball, cornea, lens, and retina. If suppose there is an increased refractive power of the eye, or if suppose there's a problem with the curvature of the cornea, the rays are coming, getting focused here. What can you do to curve this? You can put a concave lens. Okay. So what will happen? After the rays pass through a concave lens, they will come and will focus at the retina. This is a concave lens, or this is also called a minus lens. Okay. MCQ, you can again be asked that how will you identify that it's a convex, it's a concave lens. This lens, as you know, this is thin in the center and this is thicker at the periphery. When you touch the lens, you will get to know. Also, when you take this lens and you keep it on a printed note or something, you try to move the lens, the letters are going to move in the same direction of the lens. Okay, that is how you will get to know that this is a concave lens. Okay, so how will you get to know? The letters will move in the same direction. So this you must remember. This is the this you can do. You can put a concave lens either in form of spectacles or either in form of contact lenses. Okay, so you can do two. Contact lenses is a better option. Why is it a better option? Because obviously very thick spectacles, they will have a lot of aberration at the periphery. Okay, and also there's a cosmetic blemish always which is there with spectacles, and contact lenses will not have that factor. Another thing is that they will have a very wide view. Okay, and it will not. You also must know that concave lens leads to magnification of images. Okay, so also there will be not that much magnification as it happens with the spectacles as in case of your contact lens. So these are the advantages of contact lenses, but the problem is again you cannot give it to children because they will not be able to manage, and also in terms of hygiene, contact lenses are very much predisposed to causing infections. So that is the disadvantage of using a contact lens. Okay. Now, latest things which you have a lot of surgeries can happen for myopia. So I tell you what are the surgeries you can perform, refractive surgery which you can perform for myopia. Tell you one by one. The first option is that if suppose you have a very high myopia and you know that the power of the lens is 15 diopters. So altogether you move this positive power from the eye, this lens if you remove, you will be able to correct the high amount of myopia. Okay, so you have made the eye less myopic by removing this 15 diopters. So you have made the patient phakic. Okay, that means the patient does not have a lens now. So that's how you have, that is one mode of correction of high myopia. Okay. Second surgical thing which you can do to a patient is you can do a radial keratotomy. Okay. What you will do here is that suppose this is your cornea, right? You have left the central 4 millimeters of the cornea and you have made cuts in the cornea, okay, of approximately 90% thickness. So what will happen? This will make the cornea more flat. My cornea was like this. Now after doing this RK, my cornea is almost going to become flat. So this is what you did for the patient. You've done a radial keratotomy. Okay. Another thing which you can do for these patients is that you can do a photo refractive keratotomy, okay, which is called your PRK. Okay, in PRK what you do is, again, suppose you have a cornea, you have removed the epithelium of the cornea and you have given excimer laser, okay, and you have somehow flattened the cornea. So again, MCQ you must know over here that excimer laser you're using wavelength is 193 nanometers. Important question here. Excimer laser in photorefractive keratopathy, the wavelength is 193 nanometers. Another surgery you can do is, which is very popular nowadays being performed a lot. The previous surgeries are not much performed because of their shortcomings. Another surgery which you do is LASIK. Okay, laser assisted in situ keratomyosis. Okay, this is LASIK. So what you do in LASIK is that, if this is my cornea, you remove the superficial plate of the cornea, but you leave a hinge here. So you're not completely removing it, you're not completely detaching it. So it will be like opening a door here. This is the stroma of the cornea, mid stroma, and this flap you've lifted up. And after lifting this flap, you give laser. Okay, the same excimer laser you're going to give here. So what will happen again? This will make the cornea flat. Now after you flatten the cornea, you will again reposition this flap, and your cornea has now become flat. Okay, so that is what you do in LASIK. This is a very popular surgery nowadays being performed. Okay. Another thing you can do is epi-LASIK. Okay, this is almost like LASIK, but instead of removing a part of the stroma, you will just peel the epithelium. You just lift up the epithelial flap, again give laser, you reposition the flap. Okay, so this is epi-LASIK. So these are the surgeries which you might get asked, and the most important one is LASIK. Now, I'll tell you about some novel surgeries which are nowadays being performed. There's something called a phakichival. Okay. So you have a lens inside the eye, but you put one more lens inside the eye to correct the refractive error, which is of appropriate power. This lens can be put in the anterior chamber, or you can put the same lens in the posterior chamber. Okay, so you have a lens in the eye, you have your original crystalline lens, and you are adding one more lens, and that is how you will correct the refractive error of the patient. So this is one more. Another one important thing is ICL. These are called intracorneal rings. Okay, ICR basically, intracorneal rings. So what you do is that you take a ring sort of a thing. Okay, this ring is not complete. Take this ring, you make a tunnel in the cornea, and you insert this ring inside the cornea. So what will happen? It will lead to a central flattening and a peripheral steepening. So this will become steep, and this will become more, the center has become more flat. So that is how we will perform this surgery. These are very popular methods, and these are reversible methods. So you can also, if you're not satisfied, you can reverse the outcome. Okay. These are all latest surgeries which are being performed for myopia. So, I'm done with myopia. I think you're clear.